In this video, we are going to go over all the features of a parabola when it opens down. To find the root, you want to locate where the graph crosses the x-axis. So for this graph, it crosses at 2 and 4. So therefore, the roots, also known as the solutions, the x-intercepts, and the zeros are x equals to 2 and x equals to 4. You can also write these two solutions as a point where x is 2 and then the y value is 0. And then the other one, the x value is 4 and then the y value is also 0. To find the y-intercept of this parabola, that's where the graph crosses the y-axis. So the y-intercept for this parabola, it crosses at -8. So therefore, for that point, for the y-intercept, x value is always 0, and then the y value here is -8. The vertex of a parabola is either the highest or the lowest point of the graph. So because our parabola opens down, it's going to have a maximum point. So you're going to locate the highest point on this graph, which is right here. So for that point, if you go towards the x-axis, it will tell you the x value, and then go towards the y-axis, it will tell you the y value. So the point for the maximum here is 3 and 1. The axis of symmetry is the line that goes right through in the middle of the parabola. So it basically cuts the parabola in half. And because this vertical line goes through the x value of 3, so the equation for this line is x equals to 3. And as you can see that the axis symmetry and vertex, they meet. So therefore, if you know the x value of the vertex, then you would know the equation for the axis of symmetry because they share exactly the same x value. To find the domain of this parabola, you're reading the graph from left to right. So because you're reading from left to right, when you write the domain, you're only writing down the x values. So you're going to place your pencil vertically on the graph like this. And as you can see, when you place it on the left side of the graph, it starts at an arrow. So that means that the graph is going to continue go towards the left side and it's never going to stop, and your numbers are getting smaller. So therefore, the domain starts at -infinity. And then as you move your pencil towards right, you will see that it also ends at infinity. So that means the graph will continue goes towards right. So your x values are going to get bigger and bigger. So therefore, it ends at +infinity. And when you have a domain from -infinity to +infinity, you can also write your answer as all real numbers. To find the range, place your pencil from the bottom of the graph and then you're going to the top. So you go from bottom to top. And as you can see, when we start at the bottom, we start with the arrows. So therefore, the range is going to start at -infinity because it's going to keep going down. So your y values are getting smaller and smaller, and it never stops. So that's why it's from -infinity. And now move your pencil up, and it's going to stop right here. So the y value for this point, which is also the vertex, we know from earlier it was 1. And because this point is closed, you're going to use the bracket. So another way to write this answer as an inequality is that the range contains all the y values below 1. So you can rewrite this as y is less than or equal to 1. To identify whether the graph is increasing or decreasing, you're going to read the graph from left to right, just like when you're reading the domain. So therefore, when you write the answer for increasing and decreasing interval, you're writing the domain for it. So you're going to place your pencil on the furthest left side of the graph, and you're going to trace the graph. And you will see that for this graph, as I am tracing this graph, it goes up first and then it goes down. So therefore, I'm going to go ahead and write the domain for the increasing. So on the left side, as you can see, we start with an arrow. So therefore, it's going to start on the negative infinity because your x value is continuous and it's going to get smaller. And then it stops increasing right at 3. And then after 3, for the decreasing, the graph goes down. And again, it stops at an arrow, so that means it continues. So therefore, your domain is going to be positive infinity because your x values are getting bigger as the graph goes down. And you can write your answer as an inequality. So for the first one, any x values that is less than 3, your graph is going up. So you can rewrite this as x is less than 3. And for the domain, any x values that's bigger than 3, your graph goes down. So you can say x is greater than 3. The part of the graph that is positive is when it sits right above the x-axis. So right here. And when you write the positive interval, you're reading the graph from left to right. So therefore, you're writing the domain again. So place your pencil vertically and it starts at 2. And then when you move your pencil towards the right, it stops right at 4. So to write this answer in the inequality form, all your x values or the domain is between 2 and 4. So therefore, you're going to put x between 2 and 4. And the parts of the graph that is negative is where it sits below the x-axis because that's where all the negative y values contain. So to write the domain for the negative portion of the graph, you're going to start on the left side again. And as you can see, we start on the arrow on the left side. So the domain starts at negative infinity. And move your pencil towards right, and it's going to stop at 2 for the first portion of the graph. And then for the second portion, you're going to say union, and it's going to start at 4. And then it stops on the arrow on the right side, so therefore it ends at positive infinity. So to write this answer in the inequality form, for the first interval is all the x values that is less than 2. Union means or. And then for the second interval is all the x values greater than 4. To find the end behaviors of this parabola, you're looking at the ends of the graph, where you want to know what's happening to your y values as either x approaches to the positive infinity or to the negative infinity. So the best way to find that out is to simply write down the signs of the quadrant where the graph ends. So for the first end part of the graph, it ends in quadrant 3, where both your x values and your y values are negative. And then for the second end of the graph, it's in quadrant 4, where x values are positive and the y values are negative. So now we can write the end behavior. So let's start with the one on the left side. So this means that as x approaches to negative infinity, y is also approaching to negative infinity because your arrow is pointing down. And then for the second end behavior, as x approaches to positive infinity, y is also approaching to negative infinity because your arrow is pointing down.